In this lecture, we are going to discuss moment area method, which is used to determine deflection and rotation at a certain point in a determinate structure. Moment area method is basically based on two theorems. The first one is associated with rotation, and the other one helps us with the calculation of deflection. Let us first try to understand these two theorems. Consider a simply supported beam subjected to an arbitrary loading. Some internal force moment will be produced within the beam. And assume that this is the moment diagram produced because of this loading. After that, what you're going to do is you are going to divide this M with the product of E and I, where E is the modulus of velocity and I is the moment of inertia. And together, the product of E and I is called flexural rigidity. And this is the elastic curve shown by the blue line. And this is the rotation at A point. Let's call it as theta A. And this is the angle at B point. And this is theta B. Now the first theorem states that the change in slope between any 2 points. Let's take this A point and this B point. The change in slope between any 2 points is equal to the area under M over EI diagram. So if I calculate the area of this M over EI diagram between this A point and this B point, this is A point and this is B point, I would get the difference in slope or the change in slope, that is this value. So how do you read it? This is the change in slope at B point measured with respect to the tangent extending from A point. So this is theta B slash A. You can also write this as theta B minus theta A. And if I try to write this statement in mathematical form, it would be something like this. So the change in slope at B point with respect to the slope or the tangent at A point is equal to the area of M over EI diagram. So this M over here is moment equation in terms of X. So if you try to integrate it between those 2 points, between those two limits A and B, you would get the change in slope at B point measured with respect to the tangent extending from A point. Now let's try to understand the second statement or the second theorem of moment area method. So let's say this is the tangent extending from A point, and the second theorem states that the vertical deviation of the tangent at point B, the vertical deviation of the tangent at point B on the elastic curve. This point B is lying on the elastic curve. This is the elastic curve. And this is the vertical deviation. Let's represent this vertical deviation as T B A. That is the vertical deviation at point B measured with respect to the tangent extending from point A. So the vertical deviation of the tangent at point B on the elastic curve with respect to the tangent from another point A, equals the moment of the area under the M over EI diagram. So what does this mean? So it says that if I take the moment of M over EI diagram with respect to a certain point, let's assume that this is the centroid of this figure, and if I take moment of M over EI diagram with respect to this point, let's call this distance perpendicular arm as x bar, this would give me this TB slash A, which is the vertical deviation measured at point B from the elastic curve to the tangent extending from the opposite point or A point. And if I write this statement, theorem number 2, in mathematical form, it would look something like this, that deviation at point B measured from the elastic curve, that is the blue line, with respect to a tangent extending from the A point is equal to moment of area of M over EI diagram. So this term here is the area of M over EI diagram, and this is the perpendicular arm, a moment arm of this area with respect to a certain point. Instead of taking moment of M over EI diagram here, if I take moment of M over the EI diagram at this point somewhere here in the middle, what would happen? So if I take moment of M over EI diagram with respect to this point, I would get this vertical deviation. TC/A, which is the vertical deviation at point C measured with respect to the tangent from point A. And this is the actual deflection, delta C. Another important point, what if I take the moment of M or EI diagram lying towards the right of this point, that is this area. And let's say this is the tangent extending from point B. So if I take moment of M or EI diagram lying towards the right of this point, I would get this vertical deviation TC/B. That is vertical deviation at point C measured from the elastic curve to the tangent extending from point B. In the next video, we are going to apply these two theorems to solve the problem.